Hello, everybody. Our topic today is type systems. We are in the theory part of the principles of programming languages, and we want to talk about the type systems that are the mechanism behind a lot of what happens in our programming while we program. We will talk about the purpose of the type systems. We'll talk about different types of type systems. We'll talk about statics, dynamics. We will talk about strong and weak. We'll talk about different types and how they're implemented. So we'll talk about pointers, their problems, solutions, and all kind of things that have to do with the type system. And the first question we need to deal with is what is the purpose of the type system? The list of uses for the type systems that we got in the audience is space efficiency, memory interpretation, reliability of commands, readability, and things like comments, in a sense, is giving comments to code and abstraction. Now, the real answer is obviously this one, which is memory interpretation, and I want to talk about that a bit and explain why it's true. That is the reason why the whole business of type systems began. And everything else was offshoots, which is pretty much, it's nice to have, but we might, forego on it. But the first one you can't forego. The first one is the main reason why we have type systems. And let's explain. Memory, in a sense, is just linear um, bits or bytes or however you want to group them together of raw data. Which means that if we used to draw memory the following way, we say, okay, this is a word, and we have the next word, and we have the next word, and each one of these words is made up of 32 bits or 64 bits, or whatever it is. It doesn't really make a difference, but it's just consecutive data in memory. Now, this data obviously has all kinds of internal, some kind of values. For example, if we stick here the value of, let's say, 65, so we would write something like 1, and then we would have, I don't know, let's say we have 1, 2, 4, 8, 16, 32, 65. That's our 65 in binary, right? And that number is actually equal to 65. But the truth is that it's also equal to capital A, right? It's also equal to capital A in ASCII code, right? 65 in ASCII code is capital A. So the question we have to ask ourselves is, so what is it? Is it a 65 or is it a capital A? Now you might say, what's the difference? Well, it's true, but there is a difference because besides actually giving interpretation to memory for all kinds of commands or whatever, sometimes the split is not so simple like 1 byte, 2 bytes, 3 bytes, 4 bytes, or it's a whole class. How do we interpret memory? We might have a whole bunch of bits over here, consecutive bits afterwards, and it's neither 65 nor A. These two together are just one character in UTF, right? Some other character code. And it doesn't say 65, it doesn't say A, it says something else entirely. Or we might look at 4 bytes together and say, oh, we have here a class. Or, right, we could have here just one single object. Or we could have other things. So the first question that we need to ask ourselves is, what is the interpretation of the memory? And the tool that gives us that interpretation is the type system. The type system goes and says, okay, what you have over here is a 65 in this position right here. Or look at these two together and read them together, and you have some kind of other type or other character or other value, or it's a floating point, or it's a struct, or it's anything else. So just how to interpret the memory that we're talking about is really the main purpose of the type system. Once we have a type system that knows how to deal with interpretation of data, so now we can go back and say, oh, there are other benefits to the type system. For example, space efficiency. If I knew the size of the type, I won't need to allocate more than that size. But would I go about and say and require every programmer to tell me exactly what the size is for space efficiency? Possibly yes, possibly no. I mean, we could envision somebody getting up in the morning and saying no, right? I wouldn't care, and I don't care if there's no space efficiency, and just let the guy do whatever, the programmer do whatever he wants. So would you create a type system for that? Probably not. Maybe yes. Every language would have to decide for itself. But as far as memory interpretation is concerned, so therefore, if you don't know how to interpret memory, then you're stuck. So pretty much every language out there needs to use a type system or some sort of type system, whether it's explicit or implicit. We'll talk about it soon. But every one of those of programming languages out there has to implement some kind of type system. How about reliability of commands? So what do we mean by that? It seems that it's true when I write some command like, let's say, a plus b, we have to know what the definition of that is. Is the definition of that arithmetic? That's one possibility, right? The other possibility, it can mean concatenation, right? It can mean concatenation because it happens to be two strings. It can mean 1,000 different things. And when we get to operator overloading, we'll see exactly that. That the operator plus can mean different things depending on what the data types of the operands are. So we need to know how to interpret the commands, and that's what the reliability of commands means. But here too, we ask ourselves, does every programming language have to implement that? No. A programming language can get up and say, okay, plus always means arithmetic, and we always interpret the data on the left and right side as integers or floats or doubles, and we don't care about concatenation or other things. We don't allow it, and everything will be fine. And if you want to use concatenation, use some kind of function like concat or whatever, right? As strcat, or like we have in some languages, right? Uh, one of those, and I don't allow you to overload the plus operator, the addition operator, any possible way. And therefore, if I want to give a certain programmer a lot of flexibility, I might get up and say, no, you don't. You have to interpret it a very specific way. And a different language get up and say, no, I do want to give you flexibility. So reliability of commands, in a sense, is a plus that the type system gives us. Interpretation of commands, reliability that it should function the way they're supposed to function, all that is a plus. But it's not necessarily the reason why I would go and create such a thing. I might do it, I might not. We talk about readability. Readability, in a sense, is saying, okay, so a person who wants to read your code, he doesn't want to see a variable and not know what it is. He wants to know what it is so he can go and afterwards use it in the correct way or understand commands in the future the same way. So this is pretty much an answer that says things like, oh, put comments in your code so a reader can read it. Yeah, writing something like student S is, in a sense, comments in the code, even though it is part of the code, but it's putting all kind of tips right inside the code such that anybody who wants to read it has an easier time of reading it. So that's a readability issue. But here we have a writability offset. So I don't want to write it. I'm not interested. I want to let the compiler decide what the type is and let it do its job. And there are languages out there, we'll talk about them in a minute, all kind of dynamic languages, that say, listen, I don't care about the readability so much. I think it doesn't make it does, or I would say it does not make the readability less readable, and therefore I'm not interested in putting in all kinds of types into the code. So we have a readability, writability, tension, but it might be a good reason to decide to put it in. But again, I wouldn't go around and say, well, this is the purpose of the type system. This is something that once there is a type system, it's usable for that too. Same and last thing is true for abstraction. What does abstraction mean? Well, if you look at student S, there's abstraction going on. Abstraction in a sense means that student S is really composed, it's a class, right? And it's composed of all kinds of parts. Things like student ID or name or last name or GPA or a whole bunch of things, your address, whatever, right? Which classes you're enrolled to, a whole bunch of things that are abstracted away by the type system. If we did not have a type system, so if we go back into our memory and we look at our memory again, so we have some student somewhere, and here's my memory, and we have some kind of student somewhere, and let's say this is the student ID, and this is, let's say, is GPA, and this is a pointer to list to the courses, pointer to link to courses. I'm just throwing a whole bunch of things, and this is possibly your address, right? So you would have to address every one of those things separately by allowing us to create a single type. Okay, saying, oh, this is a student. It's a very powerful mechanism. What allows us to do that is the type system. The fact that type system is extensible. The fact that we can add things to the type system. But again, that is not the main purpose of type systems. Think about things, type system existed a lot before things like structs and classes came about, before objects were around. Type systems are way older, which means that before we got to this abstraction theory and we allowed abstraction into type systems, we already had type systems. It just means that it's not the purpose of the type systems. It's very useful. We can catch a lot of mistakes. We can make the programming a lot simpler, a lot more readable by adding this kind of type abstraction. But that is not the purpose of the type systems. So all these are obviously benefits, which is great. All these are benefits, which is absolutely great. But the actual real purpose of the type system is to give memory interpretation. We should know what the memory has and not just assume all kind of assumptions.